for this purpose. If there are still lead deposits which were not removed by abrasive blasting, they must be removed with a vibrator type cleaner. With this unit, the proper blade is inserted into the plug firing cavity, where it is vibrated to break out these lead deposits. After these deposits have been broken out, another light abrasive blast and an air cleaning will remove the residue. After the inside of the firing end is clean, a fine wire power brush may be used to clean deposits from the threads. But remember, when using this brush, do not brush the electrodes. The inside of the terminal cavity is cleaned with a special rubber cleaning tool driven in a drill press. A water-soluble abrasive must be used to scour all traces of contamination. As a spark plug fires, the electrodes are worn away. This increases the gap spacing. The greater this distance, the higher the voltage must be to jump the gap. So, when spark plugs are serviced, this gap must be restored to its original distance to allow the entire ignition system to operate efficiently. When closing this gap, remember it must be kept parallel to provide the maximum amount of area for wear and usable time. For proper gapping, a special gapping tool should be used to carefully move over the ground electrodes and close the gap the proper distance. Be very sure that no pressure is applied to the center conductor. This is because it is mounted in a glass-hard, brittle ceramic insulator. Measure the distance between the two electrodes with a round wire-type gap gauge to be sure the gap is uniform throughout. Special care must be exercised when adjusting the gap on a fine wire spark plug, because even though both platinum and iridium are extremely tough, they will not tolerate being bent back too often. A special gap setting tool may be used to move the ground electrode over, but here again, avoid placing pressure on the center electrode. After the gap has been adjusted, it is also measured with a wire-type go, no-go gauge. The smaller wire should slip through the gap, but the larger one should not. After spark plugs have been physically inspected, cleaned, and gapped, they must be electrically tested before being returned to service. A combination cleaner and tester is used in most shops. Here, the spark plugs are screwed in finger tight to allow some air to leak past the threads. This allows the ionized air to escape and make the test more valid. Depress the high voltage test button and slowly increase the air pressure in the test chamber while you watch the intensity of the spark in the mirror. Adjust air pressure until the most intense spark is jumping across the gap. If the spark plug is electrically sound, the air pressure will be in the green portion of the dial. This indicates the spark plug will spark in the cylinder of the aircraft engine. After plugs have passed these tests, they are ready to be reinstalled in the engine. To begin with, brush rust preventive oil on the lower threads of the shell. Be sure, however, that none of it gets into the firing end cavity. Slip a gasket over the shell threads, and the spark plug is now ready to be installed. Be sure to use a new gasket, since the efficiency of the seal depends on how much the copper gasket is compressed. Used gaskets are hard, provide less compression, and usually leak. An aircraft magneto produces alternating current. This means the polarity of every other spark reverses. On an engine with an even number of cylinders, every spark in a cylinder has the same polarity, and thus concentrates electrode wear on either the ground electrode or the center electrode. To even out this wear, plugs should be returned to the cylinder next in firing order and swapped from bottom to top. For example, in a 4-cylinder engine with a firing order of 1, 3, 2, 4, the plug removed from number 1 cylinder top would go back into number 3 cylinder bottom. The one out of number 3 bottom would go into number 2 top, and so on through the firing order. The spark plug should screw into the threads in the cylinder head all the way down against the gasket. This should be accomplished by using your fingers only. But if there is any carbon or other contamination in the threads that prevent the plug from screwing in easily, it should be cleaned by running a thread cleaner through the hole. When doing this, if the flutes of the cleaner are filled with grease, the loose carbon will embed in it rather than dropping into the cylinder. When all plugs have been installed in the cylinders, they should be tightened with the use of a torque wrench, set to the torque value specified by the engine manufacturer. After this, ignition leads can be installed after wiping the cigarette clean of any fingerprints or any traces of grease, using a rag slightly damp with an approved solvent, such as trichloroethylene. Insert the ignition lead into the spark plug. Be careful, however, that it goes in absolutely straight. Then, tighten the lead nut to the proper torque value. After all spark plug leads have been installed and properly torqued, the cowling may be replaced, and the engine given a run-up and a magneto check. If the RPM drop is correct on each of the magnetos and the engine produces the proper static RPM, an entry is made in the maintenance records for spark plug servicing. At this point, let's review a couple of questions about spark plug servicing. What should be done if all of the spark plugs removed from an engine are excessively lead-fouled? Should you replace them with spark plugs having a colder heat range? Or should you replace them with spark plugs having a hotter heat range? The correct answer is replace the spark plugs with the type which has a hotter heat range. One of the reasons for lead fouling occurring was the nose core insulator was not operating hot enough to prevent lead deposits forming inside the firing end. A spark plug with a hotter heat range will not allow these deposits to form so readily. Secondly, what should be used to wipe off spark plug lead terminals? Should you use naphtha, carbon tetrachloride, or trichloroethylene? The correct answer is trichloroethylene. Naphtha leaves a film, and carbon tetrachloride is harmful to the person using it. Now for the last question. What is the best way to remove heavy lead deposits from the firing end of a spark plug? To use abrasive blasting? Breaking the deposits out with a vibrator cleaner? Or soaking the deposits loose with a decarbonizer? The correct answer is B. Break the deposits out with a vibrator cleaner, and then remove residue with an abrasive blast. Some ignition system troubles may be caused by the magneto, and some by the spark plugs. But the link between them, the ignition leads, must also be carefully examined where there is an ignition problem. Since the ignition lead must conduct high voltage from the magneto to the plug, it must withstand the electrical pressure without leaking. If there is an ignition system problem, examine the entire harness for indications of physical damage. Then, use an electrical leakage tester to determine whether the insulation resistance is high enough and there is no leakage within the harness. Be sure there is no oil or grease on the terminal end of the lead, for even a fingerprint will provide enough oil to cause high voltage to leak off to ground before it can build up enough to jump the gap in the plug. We have now seen the workings of an aircraft engine ignition system and can begin to understand how proper maintenance affects the reliability and performance of this vital system. It is hoped through this training series, your ability to maintain these systems has increased. For it is only through your efforts as a professional aviation technician that smooth engine operation and safety in the air can be obtained.